Hi everyone, today what we'll be doing is time payments and paying off a loan. So what does this actually involve? So this involves interest being charged at regular intervals, okay? And the amount that is being paid off of the loan regularly, so it does involves someone borrowing money and interest is applied first, so that's charged every single time, and then repayments are made. But repayments is also another word for installments, so it can come up in questions, so just make sure you know both. The term reducible interest represents the interest calculated on the amount that you have been owing. The amount of interest in each time period decreases. And this is because the interest depends on the principal, and if the principal decreases, the interest also decreases, and you understand it in the question when that happens. And this process is repeated until the amount reduces to zero. Okay? So this applies to, like, say for example, a lot of bank home loans where you're paying off a mortgage. All right, most of these questions will be based on that. You can have a look at this example one later on if you want to, but I'm going to skip over to the first question first. So a couple borrows $150,000 to buy a house. At the time they take up the loan, the annual interest rate is 9%. They wish to repay the loan over 25 years. Calculate the monthly repayment. So, first of all, we've got to find out what A value do we have to arrive at the end. Because this repayment is made monthly, it will be a good idea to actually find out everything else in terms of months. Okay, so what we're going to do here is this 25 years, I'm going to make that 25 times 12, which is basically 300 months, as well as this 9% here. If I do 9%, which is 0.09, then also divide that by 12 to make it a monthly rate, that will be 0.075. So A1, which is what happens after one whole month, starts with 150,000. We're going to multiply this by 1.0075 because at the beginning they borrowed this much money, and what they've done is they have increased it by some amount of interest because the bank charged them. And at the very end of this month, we're going to subtract M, where M is our monthly repayment. Then when we go to A2, this amount in A1 is now what's owing. Okay, after the monthly repayment has paid, it might be like $1,000 or something like that. Then the same thing repeats. So we're now at the beginning of the second month, and we have to charge this person or this couple interest, and then we've got to minus a repayment. So they paid some bit of it off, and eventually this value A2, A3, A4, whatever it is, okay, eventually when you get up to A300, it's meant to equal to 0. So the way we expand this is by doing the same thing as before. We increase the powers of that interest rate, so the 1.0075. Like that. And I would recommend finding out A3 as well. So A3 will be A2's amount, which I'm just going to copy and cheat here. There we go. And we're going to do the same thing, which is multiply 1.075 minus M. And that will get us 150,000 times 1.0075 cubed minus 1.0075 squared M, and so forth. Okay, there we go. Now, this is easy for us to actually generate a pattern and recognize what can we actually factorize out. So out of each of these at the very end, we can actually factorize out a negative M and leave these two terms multiplied here. Okay, we can leave them at the beginning. All right. Then minus m, bracket, and factorize from the end. So we'll get 1 plus 1.0075 plus 1.0075 squared, like that. And what we do is you write dot 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 like that, A300. Okay, so we see what happens after 300 months. If we have a look at the same pattern here, if this is 150,000 times 1.0075 to power 3, that's the same as this 3. So if this is 300, then it should also start with 150,000 times 1.0075 to power 300. Then when we minus m and write 1 plus 1.0075 and increase each of those powers by 1, the last term, if we have a look at the pattern of these, the last line, that number there is 1 less than this number here. So if this is 300, then this should be 299. Okay. Then what we need to do is we have to set A300 as 0 because after 300 months we owe nothing. We've repaid the loan. This is now equal to 150,000 times 1.0075. It's about 300. And what we can do is use the sum formula on this. Now, I want to address that the first term is actually 1.0075 to power 0. And the last number here minus this first number as a power plus 1 gives you the number of terms in this series. So if I do 299 minus 0 plus 1, that's equal to 300. So 300 terms are right here. So we're going to write 1 bracket 1.0075 to power of 300 minus 1 over 1.0075 minus 1. Okay, I'm going to move this term over to the other side. It's m times 1 bracket 1.0075. Actually, I don't need that 1 anymore. 75 to power 300 minus 1 all over this number, which is simply 0.0075 anyway. That's equal to 150,000 times 1.0075. It's about 300. Okay, so now our last thing to do would just be to move this whole fraction over, and I simply just move that over and change that sign to a division. So I'm going to write what's on the right side. That, then divided by 1.0075 to power 300 minus 1 over 0.0075, and that will get me 1,258.7945, which is approximately 1,258.79. That's it. All right, moving on to question 2. Harrison borrows $15,000 and agrees to repay the principal plus interest in equal monthly installments over 3 years. If a reducible interest of 0.5% per month is charged on the amount owing, find the amount of each monthly installment. Right, so it seems like this has been put into months. Okay, this repayment, which is also the word installment. We've also had interests, a reducible interest of 0.5% per month. And this is over 3 years. So this is the only thing that's not in months. So just make sure that you understand that these 3 years mean 36 months. Now, A1 was firstly equal to $15,000 times by the rate, okay, and this is going to be 0.005, If you add that with 1, you get 1.005. And at the very end of the first month, you have to repay a monthly installment. Okay, so because you want to repay this loan that Harrison's on. So you minus M. So then A2, what you do is you get the first value, and then we do the same thing as before, where we increase this amount because the bank wants them to pay interest. So we increase this by 0.5%, and then we subtract a repayment that they pay off. We expand the 1.005. Okay, all right. So at this moment, look, if you really don't want to do A3, that's okay, because you can kind of see a pattern coming, but by the time you've done a lot more questions, you kind of recognize it. So we can actually stop there if we want. Minus M, the bracket 1 plus 1.005, like that, and you know that this is going to increase by 1 power. Okay, so we're going to go on to A36. So we're going to start off with 15,000 times 1.005, but to power 36, because this is the same number as this number. And we're going to carry on and write minus M, bracket 1 plus 1.005. Now if we have a look over here, the power of 1 is 1 less than this number. So 1 less than this number would be the number 35. So I'm going to increase this by 1 power. Whoops. Until the last term is 1.005, but to the power of 35. Okay? Then, you know that A36 is going to equal to 0, right? So 0 would equal to 15,000 times 1.005 power 36 minus M times, and then we sum this up, and remember that this would have 36 terms rather than 35. All you have to do is get that to be 1.005 to the power 0, and then 35 minus 0 plus 1 is 36. So, we'll use the sum formula. So you go and apply it. Okay? And then we have to find out what M is. So we've got to grab this whole bunch of terms to the other side. So that M times 1.005 to the power 36 minus 1 over 0.005 is equal to 15,000 times 1.005 to the power 36. And we simply move this to the other side by just dividing it through. So M would equal to whatever this is. But we're going to divide by this. Okay? And then on our calculators, the monthly repayment is going to be $456 and about 32.9 cents, which roughly speaking to the nearest cent will be $456 and 33 cents. So this person, Harrison, what they've got to do is they have to pay off $456.33 every single month for 36 months, which is 3 years, in order to pay off this loan, as well as the interest that has been charged throughout the loan. Okay? Right, let's go into 3. A couple borrows $70,000 and agrees to repay the principal plus interest in equal monthly installments of $M. Reducible interest of 0.65% per month is charged monthly on the amount owing. Show that the amount owing after 3 months is given by this. Okay. Right. So just before I go on, there is space on the next page over here. So you might want to continue there as well. Okay, because it's going to take a little bit of space. So it says, show that the amount owing after 3 months is given by this. So basically we do our A1, A2, A3, and we show all our working out towards that. So you can write a little bit small to fit it in. We start off by borrowing 70,000 over here, and the interest is 0.65% per month, which is in line with the monthly installment. So we don't have to change that interest rate at all. So we just have to do 1.0065 as it is, and at the end of that first month we minus M. A2 will be what was owed at the end of the first month, and then from there the bank would charge again 0.65% interest, and then we minus M. So that would equal to 70,000 plus 1.0065 squared minus 1.0065 M minus M. Then for A3, okay, what we're going to do is the same thing. So we're going to get A2's amount times by 1.0065 minus M, and that's equal to 70,000. Oh, you know what? I think I stuffed this up. This should be at times there. Sorry about that. So now this would be 1.0065 cubed minus 1.0065 squared M minus 1.0065 M minus M. Okay? Then we can try to make what this is wanting us to do. So the 70,000 times 1.0065 to the power 3 is already there. That's okay. We just got to factorize a negative M out. So we write A3 equals the beginning. We don't have to change anything at all. Minus M bracket 1 plus 1.0065 plus 1.0065 squared. Okay, which is exactly what they have here. Right. Question B. Write an expression for the amount owing after n months. So previously, in a question, we've always had some final value here. And the last question we had, I think, 300. Let me just have a look. No, we had 36. Okay? And that was because in the question they said, they have to pay equal installments over 3 years. But in this particular question, we don't know how long it's going to take. It just says it's going to repay after n months. So basically, we have to find out what an is. So if this is n, and this was 3 and this is 3, that means that the first power of 1.0065 has to be to the power of n. Now let's have a look at what this actually goes up to here at the very end in these brackets. So if I just copy down these first 3 terms, and then plus dot 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 plus the last term. The last term would always have 1 less power than this number. So 1 less power than this number would be to the power of n minus 1. And there we go. So find the amount of each installment in question C to the nearest dollar if the loan is repaid at the end of 10 years. So 10 years, remember, this is what we call 10 times 12 months, which is 120 months. Okay? So basically it's asking us to find M, and this AN value is basically A20, and A20 is going to be 0, right? So 0 is going to be 70,000 times 1.0065 to the power of 120. That's our n value there. Minus m, bracket 1 plus 1.0065 plus 1.0065 squared plus dot 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 plus 1.0065 to the power of 120 minus 1, which is 119. Okay. So, once we've done that, you know what? I think what I had to do in question B was actually carry on a bit further. So once you've written that down in question B, actually, can you write down that 70,000 times 1.0065 to the power of n is also accompanied with minus m, but we have to put this together as one. So this will be times by 1 bracket 1.0065 to the power of n minus 1 over, 1.0065 minus 1, which is just this. Okay, this might be a more appropriate answer actually. All right, so once we've done that, what we can do is two things at once. We can actually bring all this to the other side and also apply the sum formula to a series. So that will be 1 bracket 1.0065. Now that will be to the power of 120. There's 120 terms in here. Over 1.0065 minus 1. And there we go. So all we have left to do is find out what our m value is. Okay? So m, oh, and you know what? This should be actually here. I missed out something. That should be times 1.0065 to the power of 120. We can move this to the other side. So m would equal to 70,000 times 1.0065 to the power of 120. But we divide this by this whole amount. Okay, and that will give us a monthly repayment on installment of $841.91.36. So if I round that, that will be $842. That's it. Okay, let's go on to question 4. So in question 4, Meg borrows $200,000 to buy a house. The rate of reducible interest charged on the loan is 0.425% per month. If M is the amount of the monthly installment and the loan is repaid after n months, show that M is this expression. So it kind of skipped out the first few steps of finding, what A3 is, and then just skipping up to that question where we know that AN is going to be 0 because you don't owe anything, and it wants you to find expression for the monthly installment. So we've got to do the same thing as before. A1 is 200,000 times 1.00425, so it's 0.425% per month, and then we minus the repayment. Okay. Then A2 would equal to this amount, but we're going to multiply this by 1.00425 minus m. So that expands to give you 200,000 times 1.00425 squared minus 1.00425m minus m. Okay, whoops. So A3 will now be this whole line from A2 multiplied by 1.00425 minus m once again. And then we have to factorize out minus n from the end. 1 plus 1.00425 plus 1.00425 squared, like that. Then we can find out what a n is basically. Oops. So an is going to equal to 200,000 times 1.00425 to the power of n minus m 1 plus 1.00425 plus 1.00425 plus all the way up to 1 plus 0.0425, but this will be to the power of n minus 1, which is 1 less than the first subscript term here. Okay, so the n months that it says. Now an has to equal to 0 for this repayment to be paid off. So we make that equal 0, and we're going to bring all this to the other side whilst actually applying this sum to geometric series. Yep, like that. And on the right side, you just get this amount left. Okay. Now let's have a look at what they actually want us to prove. Okay, they want us to prove this statement. So we do have this over on this side. We're just going to multiply what this result is to the other side, which is 0.00425 anyway, and we're going to divide this one over. Okay, so let me just simplify this first, just so that I know I'm doing one step at a time. So this bit here will be 0.00425. Then I'm going to multiply this over and divide this bit over. So that m is 200,000 times 1.00425 to the power of n times by 0.00425. This is all over 1.00425 to the power of n minus 1. Okay, and that will give you exactly the same thing as what they have here. So we've just calculated an expression for the monthly repayment. Then for question B, it says find the amount of monthly installment if Meg agrees to repay the loan over 30 years. So 30 years represents 30 times 12 months, which is the same as 360 months. So we're just going to substitute in n as 360. Okay, like that. So that m would equal to 1.0, oh no, it'll be equal to 1085.899 ... But m will be, roughly speaking, 1,085.90 cents. Question C. How much will Meg pay in total over 30 years? So in 30 years' time, this monthly repayment includes interest. So we're going to multiply this by 360 of them. So Meg pays 1,085.90 cents times 360. So what that will give us is 390,924. So looking back at the question, we have Meg borrowing 200,000, but we've actually got Meg to pay off $390,924 in total. That's almost double of what she actually borrowed. So, in question D, if Meg decides to pay the loan over 20 years instead of 30, how much money will she save? Well, let's find out how much she would actually pay off if it's 20 years. 20 years worth of repayments is the same thing as 20 times 12 months, which is 240. And the monthly repayment that you have to get is indicated by this formula, which I'm just going to copy down. Okay, so that monthly rate there, okay, a monthly installment, sorry, I should say, not rate, is going to be this formula, but it's going to be raised to the power of 240 rather than n. So I'm just going to delete those two. Sticking 240 there. So this gives me one monthly installment, but you got to multiply this by 240 because this person has to pay 240 of them. So I'm going to remove that as well. And what's going to happen is this amount would equal to 319,436.3715. Okay. Let me just double check that it actually has more numbers after that. Just give me 1 second. Nope, okay, that's all that it says on my calculator, so I'm just going to stick with it. And then what I'll do is, if I have a look at the previous amounts, this should be more because we're taking a longer time to actually pay off this loan compared to 20 years. So if I pay it off for 30 years, then this is the total amount that Meg will pay. If Meg pays it off over 20 years, then she'll pay this amount. So how much will she save? It will be the subtraction of those numbers. So we're going to get 390,924. Then we minus this amount that we just got. So that will give us 714. Let me just check. 71487.628. Oh, and there's more numbers. So you know what? 3715 is not just it. I think there's more numbers after that. But it just didn't fit on the calculator. All right, then that would be approximated to 71,487.63. Okay, and that's it.